Hi, welcome to a new virtual tour of the European Southern Observatory, also known simply as ESO. My name is Farid Char, and with the producer Hector Salas, we are going to be your guides on this journey to ESO's La Silla Observatory. So, some information from about me. Well, I am one of the tourist guides of Paraná Observatory actually for more than 10 years. And I have several years of experience in astronomy outreach and education, and I have been working also in places like the Astronomy Center of the University of Antofagasta and so on. But today I am not alone. I am with Hector. Hector will be the producer. Hello, Hector. How are you?
Hi Farid, I'm happy to be here once again. So I'll introduce myself. I'm Hector Salas. I'm a PhD student at the Leibniz Institute for Astrophysics in Potsdam, Germany. I work mostly with topics related to the circumgalactic medium, that is the environment that immediately surrounds galaxies. And I have been a member of the team of guides for Paranormal Observatory since 2019. I joined while I was doing my master's in Universidad Antofagasta. And as Farid mentioned, today I'm going to be the producer, and that means that I will be switching the videos and pictures, but also I will be taking a look at all your comments and all your questions. So please send any doubt that you might have, any comments, and Farid will answer them at some point during the tour.
Okay, thank you very much, Hector. Yeah, that's right. ESO would like to join you during these virtual tours and taking astronomy directly to your homes or wherever you are. So please send your questions or comments through this broadcast, and Hector will be collecting your questions or comments, and we are going to assign some moments to answer those questions. Okay. And of course, please don't forget to share this experience in case you enjoy it. Okay, yeah, using the share buttons of on Facebook or YouTube. Okay, so now we are going to start this virtual tour. We are going to begin explaining a little bit about the European Southern Observatory. So we are going to talk a little bit about the organization. So ESO is an intergovernmental organization containing 16 member states. Its headquarters are located in Germany, and Australia is one of the strategic partners, and Chile is the host state and home to all ESO's observatories. Since the 60s, and with the purpose I mentioned, ESO chose one of the best places on the planet to carry out astronomy, the Atacama Desert in Chile. At that time, our country had started a site exploration campaign to attract international observatories such as ESO to our country. So Chile offered land, and ESO chose the area that looked best. Okay? So ESO's mission is to design, build, and operate astronomical observatories. And what for? To enable important scientific discoveries and foster cooperation in astronomy. So this picture, you will see a picture in a few moments, will show you the three observing sites of ESO in Chile. So first we have the Paraná Observatory. This observatory is home to the Very Large Telescope, or VLT, and this is currently the most advanced visible light telescope on Earth. In the future, the Paraná Observatory will also host the Extremely Large Telescope, or ELT, which will become the world's largest visible light telescope. And near there, we will have the CDA, an array of telescopes for the detection of gamma rays. And then we have Chajrantor, the site where the ALMA and APEX radio telescopes are located. ESO participates in those radio astronomical observatories with its international partners. And finally, we have La Silla Observatory, and this is the site you will be visiting today. This was the first observatory built by ESO in Chile, 2,400 meters above sea level. in the region of Coquimbo. So we will go there virtually during the next hour. Okay, so let's travel now to La Silla Observatory. So looking at our planet, we start this journey by land in Europe, since I must mention that ESO is an European organization. So on this map, outlined in white, we can see the different ESO member states. Chile is the host country and home to all ESO observatories. So to see the sites, we will travel to the Chilean mountain range. As we move over the Atlantic Ocean, let me tell you more about ESO's mission. To give you an idea, ESO tries to devise which type of instruments are needed to study the universe, and then designs the pieces, builds and operates telescopes responding to observational requests from all the planet, and in this case, encouraging cooperation in astronomy. Okay, we are almost there, and in a few moments, we are going to take a look at this amazing mountain. So, in a few moments, we are going to see a mountain range with some domes. Okay, so you need to pay attention to the shape of this hill. Does it remind you of anything? You will look at the mountain now. Perhaps a horse saddle. Well, in fact, the mountain itself and the observatory later were named after a saddle for horse riding. So over the years, ESO's La Silla Observatory has become the perfect viewpoint for studying the universe. Well, it was chosen by the astronomical community as an observational site at the beginning of the 60s. Okay, so La Silla enjoys a large number of clear nights per year, a still and dry atmosphere, and dark skies. Okay, far away from artificial light sources which exist in cities. So this observatory was officially inaugurated by ESO in 1969, and some of the telescopes seen on the picture are now out of service. So right now, 10 telescopes are operating, and two of them are operated directly by ESO. The other telescopes, several of which are robotic, belong to other institutions, and ESO is providing support for those facilities. So now we are looking at this new video, and we can see the names of the telescopes. Okay, so we have this view of the different telescopes, and you can see the different names. Okay, so in a few moments we are going to take a look at the NTT. This is the New Technology Telescope. This is one of the important places of this virtual visit. This is the CEST. This is a former radio telescope. Now it's not in operation. The Swiss 1.2 meter telescope. The Tarot is another acronym of another telescope, the Visitor Center, and the ESO 3.6 meter telescope. Okay. So basically, this is the situation with the different telescopes. But now we are going to start this virtual experience. But in first place, we are going to visit the largest telescope in La Silla. So we are going to start by chronological order of inauguration. So in this case, we are going to start with the ESO 3.6 meter telescope, this one. So in this place in La Silla, I am going to show you the place. From this exact place, more than 1,000 people were able to saw the total solar eclipse of the 2nd of July in 2019. This was a memorable astronomical event that will only be repeated on the 28th of August and in the 2231. So a few years ago, there was a solar eclipse visible from La Silla, and we have a lot of people here. And you can see this is the landscape from La Silla. Um, We have many mountains, of course. This is the view of the CEST. This is the former radio telescope. Now it's not in operation. And we have a glimpse of the Andes Mountains. So basically, we have a very typical um, scenario of the Atacama Desert from here. Okay, so now we are going to start this visit, as I told you already, and we are going to start inside of the 3.6 meters. And here we are. So now we are inside of the ESO 3.6 meter telescope, or the 360. This is the what is like an common name by the staff of La Silla. So the name refers to the mirror's diameter. So now, back in the mid 70s, this telescope was one of the largest telescopes on Earth. So right now is hosting an exoplanet hunter. I mean, an instrument. The name of this instrument is HARPS, and this is a highly specialized instrument. And we are using this instrument every night to search for other planets, exoplanets, outside our solar system. So, what can you notice about this dome from the inside? Well, it's huge. We can see here the perspective of this dome, and basically the altitude from the first floor to the dome is 25 meters. The whole structure of the telescope is equal to a seven-story building. Now, everything seems small here as compared with the telescope. For example, can you see anyone over there? Well, I will let you some moments to take a look. And basically, we have someone here. So this person right here, I will do a close up. This person right here is just below of the blue structure. This reference helps us to distinguish the telescope itself from the rest of this structure, which you will now see in detail. Okay, so now I am going to show you some specific portions or sections of this telescope. So for this purpose, I am going to open a picture here. So I will explain some parts of the telescope. So, for example, first in dark blue, I mean this structure here. This is the structure supporting the telescope, and basically this is something that we call the mounting of the telescope. Okay, so the mounting works as a huge arm supporting the telescope and includes several systems providing power, such as electricity. And on this arm, and parallel to the Earth's rotation axis, the telescope moves to follow objects in the sky during the observations. Now, going upwards in lighter blue, I mean this structure here, we have the telescope's body, which holds the 3.6 meters or 360 centimeters main mirror and the secondary mirror. Okay, now where's the main mirror? The main mirror is not visible because it's covered by its protection system, this black structure. This is a system of tabs which open and close to protect the mirror from dust or moisture while the telescope is resting. Now, in the black tubular structure in the upper part here, we have the secondary mirror, which gathers light from the main mirror in a beam and directs this light to the instruments that analyze it. You will notice that the main mirror has a hole in the middle. Okay, so the light is sent to the instruments through this hole. So basically, we have the light going to the primary mirror. The light is concentrated and is reflected to the secondary mirror, and is reflected again, and the light is going to pass through this hole. Okay. Okay. And what is the instrument? Well, the instrument, in this case HARPS, the exoplanet hunter, is not visible because it's completely insulated in another room, in another floor of the building. So the 360 began operations in 1977, and from the beginning, it represented a challenge for engineering and for ESO as an organization. European astronomy was able to gather talents from several countries to build an optical telescope in the 4-meter category, the largest and most advanced category that existed at that time. Now, why was such a large telescope needed? Well, in astronomy, objects are analyzed through its light. The more light we collect, the more we can learn. In this case, a bigger mirror will capture more light, and therefore more information will be available. We will be able to see fainter objects and smaller details. Now, how do you think this giant telescope moves? Well, we have a short video to show you how the telescope is moving. Okay, so this was the how the telescope is moving. Of course, it's very impressive. Well, a mirror for astronomy is not just any mirror, since its shape and surface must be perfect at the scale of fractions of thousands of millimeters. So, to achieve this in the 70s, an extremely thick mirror was manufactured, with 53 centimeters thick on average. But this also implies an extremely heavy mirror. So, the weight of this mirror is 11 tons. This is the equivalent of 2 African elephants. So if we want to build larger telescopes, we need to find other solutions. So how was the next step taken? We will see it later in the NTT. Okay. Hector, I don't know if at this point do we have some questions about this telescope?
So far, we have some greetings from Basil saying hello, from Swig Raven from Amsterdam, from Yana says greet to all, from Jorge who is watching us from Antofagasta. We have here Safa Samfa, gotta pronounce that, saying hope CEST can be used again someday. But we don't have any questions so far, so let me ask you a couple of questions that people usually ask us. One of them being, what kind of maintenance do you need to do on these telescopes?
Yeah, sure. It's a very good question because, the most delicate part of the telescope is the mirror. So, in order to keep the mirror free of dust, for example, in Paranal, they have two systems to do it. In La Silla, it's probably something very, very similar. So, for example, because those telescopes are located in the middle of the desert, we need to remove dust. And in order to remove dust, there is a way, and this way needs an element. Is a carbon dioxide snow. Is something like foam. So basically, a couple of engineers they will spray this element, the carbon dioxide. They will rotate the telescope a little bit, and basically this element will remove dust. Okay, so from the mirror. So in this way, the mirror can be free of dust. And this is basically a simple, not invasive maintenance system. But there is another way, and this is more complex, and this involves to extract the entire mirror from the telescope. By the way, those mirrors are usually covered with a very thin layer of aluminum. So essentially, when I was talking about the mirror, we are talking about, let's say, a cell, but this aluminum cover is the actual reflective surface. So this reflective surface is very thin. So in this additional process, this is more complex. We need to extract the mirror from the telescope. We need to transfer the mirror to another place, and we need to do a process that is called recoating. So this recoating involves to removing this aluminum layer, and we need to put a new aluminum layer. So basically, after this process, the mirror will look like a new mirror. Okay? So after that, we need to put the mirror again in the, I don't know, some kind of platform or vehicle to transfer the mirror back to the telescope, so we can reinstall the mirror, and the mirror will look like new because the actual surface was changed. So this is basically how we can keep the mirrors in optimal shape. And of course, every day we have engineers doing other kinds of maintenance in the telescope, in the enclosure, in the structure, in the instruments, in everything. So that's how it's possible to keep the mirrors and the telescope and all the observatory in perfect shape.
Thank you. And another question: is it possible to go in person to La Silla Observatory?
Yeah, sure. And actually, something very important about uh, the ESO observatories in Chile is that you can visit in person La Silla and Paranal. So regarding La Silla specifically, yeah, you can visit La Silla uh, every Saturday. They have a tour every Saturday at 10 a.m. And the Saturdays from September to March, they also have a tour starting at 2 p.m. And between April to August, they also have tours on Sundays, and this tour is starting at 10 a.m. But anyway, in all cases, you need to do an online booking in advance to visit La Silla. So there is it's necessary to access to the ISO website, and you will find a specific section about the visits to the ESO observatories. You will find a specific section about the visits to La Silla, and you will find all the necessary options to book a visit in advance. La Silla is located, let's say, far away from the closest city. In this case, La Serena is a little bit more than 2 hours or something like that. So and the slots are limited, so you need to try to make an online booking at least 2 weeks in advance, um, and you will be able to visit La Silla and for free.
Okay, thank you. And I will put the link in the chat later.
Okay.
And finally, we have a question here. It's if the telescope is just electronic or if it actually has a proper mirror. And
Yeah, as I was explaining before, um, we have in this case a primary mirror and a secondary mirror, but the mirrors are not visible in this picture because it's covered by the tabs here, and it's covered in this case by the tubular thing here. But yeah, they are actual mirrors. It's not an electronic thing. The only electronic thing is the instrument that is in charge to convert the light coming from the mirrors, concentrated, okay, and the instrument will convert this physical light into a digital signal. That's the electronic part of the system.
all right, I think we can continue the tour for now. And I remind everybody that you can always send us your questions or comments, and we'll have a second stop during the tour to answer them.
Yeah, sure. Thank you, Hector. So now we are going outside because we are going to continue with the tour. And Now, from the outside, our next stop will be the NTT telescope, the New Technology Telescope. So I would like to highlight the differences between the domes. So keep in mind that both telescopes have almost the same mirror diameter. So the NTT, this one, was inaugurated in 1989. It has a small and very compact octagonal dome with a system of flaps. This represented, in its days, an evolutionary leap in the construction of telescopes, since it allowed hosting instruments in smaller, lighter structures with improved airflow on the inside. So basically, this is a one step forward if you compare with the more classical and massive domes such as the 360. Okay, so basically the flaps of the NTT allow the air to flow smoothly, reducing turbulence and preserving the sharpness of the pictures. Okay, so now we are going to enter to the NTT. And here we are. So do you remember the structure of the 360 telescope, right? It's a huge dome and how small our colleague seem inside. Well, in this case, the building is practically attached to the telescope. So it's a very different concept. And if we stand in front of it, we will look approximately, let's say, this size, more or less like this cabinet here. So the telescope mounting is also completely different. Here, the entire building spins around in 360 degrees. Okay, so now we can see from this perspective that all of this can spin in 360 degrees. I will show you another view from the opposite side, this one. So you can see that is more or less the same. Okay. Well, uh, now regarding the mirror, the main mirror is located here. Okay, so you can see the main mirror on let's say pale round structure. The disc here is the mirror. I will do a close up so you can see this structure here. So, and we can see that is reflecting sunlight, right? Well, do you remember the 53 centimeters thick mirror of the 360, right? Well, the NTT mirror has almost the same diameter as the 360, 3.58 meters to be precise, but it is significantly thinner. This mirror is only 24 centimeters thick. It is also much lighter, in this case 6 tons. This is like just one elephant. So to keep the perfect shape as the telescope moves, there is a system of actuators or pistons below the mirror. So the system is enclosed inside the box, inside this box that you can see below the mirror. So we have 75 actuators going up and down to keep the perfect shape. So this system is computer controlled and is called active optics. The active optics was developed by ESO and represented a significant technological development in the construction of the next generation of telescopes in the 10-meter category. Active optics has been applied to all large modern telescopes, including the Very Large Telescope or VLT at the Paraná Observatory and the upcoming Extremely Large Telescope or ELT that is currently being built near Paraná. Okay, and what about the staff? What about the people working on the telescopes? Well, around 30 people they are working in La Silla on different telescopes and doing different tasks. The scientific and technical staff is they are working from another place. They are working from the control room, and the control room is located in a building that is quite far from here. And we can see in a short video how these people is working at night. Here we are. So basically, the control room of La Silla is like an office space. So you have, in this case, you have like two big workstations, um, and they have several computers, and you can see some people working there. They are the scientists. Basically, you have the people working there all night, and basically you have telescope operators in charge of the main scientific operations, and if necessary, you have also an staff astronomer from ESO to help with these observations. Well, essentially, this place is in a separate location. Is very comfortable, of course. The people must be working there all night, but they don't need to be in the telescope. Okay, so they don't need to be in a cold place at night. They can be just in this office, and they can supervise all the night operations from there. Okay, so now with this information, I think you know a lot right now about the observatory and the staff. So now I want to invite you to see the main scientific milestones obtained from all ESO observatories, that is La Silla, Paranal, and Chajnantor. So now we are going to take a look at this important video of the most of the 10 main scientific milestones. Please, Hector.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, that was the top 10 scientific milestones from the ESO observatories. Of course, that's very, very interesting. But we have an extra result, a sort of bonus track. So please, Hector, if you can put this additional video. Okay, thank you. So this is basically something about something that happened in 2019. A team of astronomers were able to capture the first picture of a black hole. The Event Horizon Telescope, or EHT, an array of 8 ground-based telescopes distributed across the planet, coordinated by an international collaboration, achieved the first direct visual evidence of a supermassive black hole. The image will reveal the black hole at the center of Messier 87, a massive galaxy in the nearby Virgo galaxy cluster. This black hole is 55 million light years from Earth and has a mass 6.5 billion times the mass of the Sun. So this is the picture. Okay, so this is this was the top 10 and the additional important news. So as you can see, the discoveries achieved by ESO telescopes and the scientific staff is truly amazing. Okay, well, the tour goes on and the night falls over La Silla. There is no moon, so we can watch the night sky, as you can see here. So we have a beautiful sky from this observatory, and we can explore a little bit of the main astronomical objects. So if we take a look here, this is the NTT, by the way. If we take a look here, we can see a very popular constellation. This constellation is Orion. The Orion represents a hunter, great hunter, with a very characteristic three stars here, somewhat aligned, representing Orion's belt. In Spanish, you know this configuration as the Las Tres Marias. Okay, so basically, in the same area in Orion, you can see other important object. This is the Great Orion's Nebula. This is basically a star-forming region in this area, and this nebula is very bright. You can actually see it with your naked eye. So this is a very interesting object, and of course, it's very impressive with binoculars and telescopes. Okay. Now, next to Orion, not far from this constellation, we can see a very bright star here. This star is called Sirius. Sirius is the brightest star in the sky. Sirius belongs to a constellation called Canis Major. Canis Major in the mythology is one of the hunting dogs of Orion. So basically, the constellation related to Sirius is connected in the mythology to this one, to Orion. Okay, so these are very interesting and popular objects in the night sky. Now, the hunter Orion, okay, and one of the hunting dogs have been following a particular path through the sky, the Milky Way, our galaxy. This, okay, so you can see that we have a very bright section of the sky with the more, let's say, concentration of stars, and basically our galaxy, the Milky Way, is basically a huge flattened disk with a shape like a spiral shape, but we see the Milky Way as a band of light across the sky because of our viewpoint, because basically we are inside of this disk. So our Milky Way consists of around 200 billion stars and huge clouds of interstellar gas and dust. We can see the later as the dark clouds that cross the bands that cross the band of light. So we can see some areas here with dark clouds, you see, and we also can see some red clouds. So the red clouds there are basically made of hydrogen, and this is the simplest and most plentiful element in the universe from which the stars are formed. Okay, so by looking through the Milky Way, we can find two strange objects similar to clouds. We are focusing the view here. So I want to show you this. So those objects are not clouds. They are actually the large and small Magellanic clouds, our closest galaxies, okay? And at the same time, they are smaller than our Milky Way. The name Magellanic Clouds refers to the records of Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So at that time, no one has any idea about what a galaxy is. So Ferdinand Magellan was recording these objects as clouds, basically. So that's why we know those objects right now, like the large Magellanic Cloud and the small Magellanic Cloud. Well, so right now I want to show you something else, and this is located in this side here, and I will try to put this in the center because I want to show you the smallest constellation in the sky. I want to show you the Southern Cross. This is the Southern Cross. This constellation looks like a cross, of course. In this picture, is like a tilde, and it's a very important way to find something that we call the South Celestial Pole. This is basically a point in the sky. Of course, it's an imaginary point, and in this case, the stars appear to revolve around this point at night because the South Celestial Pole is essentially the projection of the uh, south of the geographical South Pole in the sky. Okay, so in order to find this point, the South Celestial Pole, we can do two things. We have two ways to find this point. One way is to create some kind of triangle with the Magellanic clouds as the corners. Okay, so basically it's something similar to um, to a triangle because the South Celestial Pole is more or less here. Okay, so you have a triangle here, right? So the South Celestial Pole is more or less here. But the second way to find this point, in case, for example, we don't have the Magellanic clouds in the horizon, in the sky, is to use the Southern Cross. So in order to do it with the Southern Cross, we can project the longer stick, this one, 4.5 times. So basically, when you do this, I will do it now. And we can project one, two, three, and 4.5, and more or less like here, we have the South Celestial Pole. So what happens here? During the night, as I told you already, you have the stars that appear to revolve around this point. So if I take an astrophotography of long exposure, you will see something like circles here, concentric circles around this point. Okay, and finally, if you are able to locate the South Celestial Pole and you, let's say, you outline a straight line to the horizon, basically you are looking at the south cardinal point. So this is a very nice way to find the cardinal point, in the cardinal points, in case you are, I don't know, lost in the desert. Okay, so this is basically what happens here. Now, if we continue a little bit, if we go back to the 360, we can see here that at this time, at the time of this picture, we have the center of the Milky Way rising over the horizon, right? So here we have the center of the Milky Way rising, and this is very easy to recognize because this area is wider. You see, we have a bigger area here dominated by dark clouds with more stars. You see, so basically we have very prominent structures in this area. So basically, the Milky Way in this picture looks very nice, and just next to the center of the Milky Way, we have this area here, and you can see, let's say, yellow or maybe a little bit orange star here. This is the brightest star of the Scorpius constellation. Its name is Antares. So, for example, Antares is very easy to find in the sky, and Scorpius is a very popular constellation in the sky. Um, when you want to find the center of the Milky Way. Okay, so this is what happens here. We have this interesting, very nice view let's say below, behind of the 360. Okay, but I want to show you something else. I want to show you another perspective here. So in this additional view, we are in the platform of the 360 at night. We have another very beautiful view of the night sky from here, but I am using this picture also because I want to highlight that if you see here, we have something like a glare. We have something we have light here. Well, basically, this is light pollution from La Serena, and this is a very important problem for astronomy. Light pollution is a problem for any observatory, and that's why in Chile, for example, we have um, some kind of legal normative to minimize the light pollution around the astronomical observatories. Well, in this case, it's very important to keep this problem under control because the night skies are basically a natural heritage of northern Chile. So that's why we need to protect this heritage because, well, right now Chile is let's say, is the epicenter of astronomy, on Earth. Well, anyway, now we are almost finished here, so I will rotate a little bit this view, and I will show you at a distance. In the distance, you can see the telescopes of La Silla here, and I will show you the road of the observatory coming from the 360, passing over all the telescopes here, and this road is basically connecting all the telescopes, but eventually you are going to reach the residence of the La Silla Observatory. So the residence or the hotel is located here. Okay, so we are going to move to this place in a few moments. I just want to show you that we have a lot of different telescopes here. As I told you already, some of them are not in operations anymore, but this is a very important legacy for astronomy because, well, at some point, La Silla was one of the largest observatories on Earth. So, and right now, we are still doing operations. We are still working with the 360, with the NTT, with the 2.2 meters telescope also. So basically, La Silla has more than 50 years of operations and is still going. So uh, basically, La Silla is a very, very nice place to visit, and it's a very important place for important scientific discoveries. Okay, so now I am going to move to the hotel, and again, we have a beautiful view from here. This is the center of the Milky Way. So this picture, for example, was probably taken in winter in the southern hemisphere. We have winter in, let's say, June, July. So at this time, the center of the Milky Way and all the Milky Way is visible in the sky. This is an important difference if you compare with the northern hemisphere, because in the northern hemisphere, you cannot see the entire Milky Way, and you cannot see the Milky Way in the zenith. You cannot see the Milky Way just above you. So that's why the southern hemisphere is so interesting for not only for astronomers but also for astrophotographers. So in this case, this is the perspective of La Silla, the hotel of La Silla, and this person is the photographer. So basically, all the pictures we saw in this virtual tour were taken by him. So and here you can see a little bit of this facility. This is basically the place for the staff. So the staff can come here and they can rest. They have dormitories and they have a dining room and all the necessary things during the work in the observatory. Okay, so Hector, I think we can now take a look if we have some additional questions.
We don't have any more questions from our audience today, and I think we are ready to just end the tour at this point. Also, I would like to remember everybody that you can find all the pictures, videos, everything on the ESO website. where you can just have hundreds of pictures, thousands of videos, and you can find these 360 tours that you can walk at your own pace. And we're doing tours every Saturday, virtual tours, and also in-person tours. But for the virtual tours, we're switching between the Sea Observatory and Paranormal Observatory, also between Spanish and English. So keep an eye on our social networks to know which tours is going to come next. And please share this with everybody that you know that might be interested. And with that, I will say goodbye. It was my pleasure to be with you today.
Okay, thank you very much, Hector. So yeah, I would like to remind you that all the visits and information, pictures, and material are available on the ESO website. Also, you can share your feedback about this virtual experience using a survey. Um, uh, you can find a link for this survey in a few moments. And well, of course, please stay updated because in the ESO social networks, we are going to announce when we will have the next virtual tour. It could be in Spanish or English, it could be Paranal or La Silla. Okay, so from my side and on behalf of ESO, I want to thank you very much to everyone for joining this virtual experience. So see you soon and thank you very much.